All right, we're asked to determine the rate law for this hypothetical reaction, which essentially means that we need to determine what the value of m and n are, the exponents in this rate law. They tell you how the rate depends on the concentration of A and on the concentration of B. In order to do so, we need to compare trials where only one of the two reagents has this concentration changing. So, for example, to determine with respect to A, we need to compare trials 1 and 2 because we see the concentration of B is constant. To determine the dependence on B, we can compare trials 2 and 3 because A is constant and B is changing. All right, so if we look at trials 1 and 2, we see between trial 1 and trial 2, the concentration of A has increased by a factor of 1.5. And if we look at the reaction rates, we see that the rate has increased by a factor of 1.5. So we know that the reaction is first order or directly proportional to the concentration of A. What is not immediately clear is whether or not or how the reaction order varies with respect to the concentration of B. All right, so we just determined that the reaction rate is first order with respect to A, and we're interested in looking in to determine what the value of N is. What is the order with respect to B? And we're going to be looking at trials 2 and 3 here because the concentration of A is constant and we've changed the concentration of B. All right, so we're comparing rate of trial 3 to rate of trial 2. We see that K is going to cancel out, and also the concentration of A raised to the first power is going to cancel out because, again, we see these two concentrations are the same. So we can simplify our expression. All right, so what we've done here is we've input the rate of trial 3 to the rate of trial 2, and here's the concentration of 3 to the concentration of 2. All right, and we calculated these numbers, and to me, the value of n is not obvious. So what I'm going to do is to take the log of each side. All right, so we're going to use the property of logs that if we take the log of x raised to the power y, y is going to come down in front, so this is equal to y times the log of x. So we take the log of each side of this equation. We end up with log of 1.95 is equal to n times the log of 1.25. We simply solve for n. All right, so we solve out for n, and we see this is third order with respect to b. And summarizing our rate law, as rate is equal to k times a raised to the first power, b to the third.